Hello, what we are going to do tonight is we are going to be reviewing sections 2.7, which is absolute value equations, and 2.8, which is linear inequalities and absolute value inequalities. We are going to first look at absolute value equations. If you look at this first slide, it is asking us to write an equation for each translation of the graph of y equals the absolute value of x. If we are writing an equation, the first thing we need to know is the function formula. The generic formula is y equals a, which is our factor, times the quantity of x, absolute value of x minus h, and then plus k after the absolute value. If we look at this, it is telling us that we need to write an equation that is up 4 units. So we're going up 4, which we know talks about our vertical shift. And then we are right 2 units. So right 2, which is our horizontal shift. So what we're going to do is we're going to replace h for our horizontal shift. The right is our horizontal direction, which is going positive 2, so h is 2. And k is our vertical shift, which is for this direction up, and it's going positive up 4, so k is positive 4. They did not tell us anything about a, our factor, so since there was nothing specified about that, I'm just going to leave it alone. Keep it as 1 as our identity factor. So what we're going to do is we're going to replace h. So it's x minus, h is positive 4. So I'm going to have x minus, and I'm going to plug in a positive 4 for h. If you notice, since h is positive, I know when plugging a positive in times a negative, that negative sign stays there. The positive will not affect the operation in front of it. And then we have plus k. We're going to plug in, substitute in a positive 4. And we once again remember when we substitute a positive number, it does not change the operation in front. So that is how we write the equation of this absolute value. We're going to move on looking at the next 2 problems. You see here it is asking us to write an equation of each translation of the graph, where y is absolute value of x. In these 2 examples, we notice that they give us the vertex. So we need to remember that our vertex is just the point where our 2 legs of our V meet in the middle. So we look at this. Our example for our vertex is h comma k. And they tell us that our h value is 5 and that k is positive 2. So remember, we're using the same formula. So we have y equals, nothing was said about the slope, so I'm just going to leave that alone. Keep it as 1. And then it's going to be x minus, our h value is positive 5 for the vertex inside those absolute values. And k is also positive, and I'm going to put 2 behind the plus sign. There you go. Now we're going to look at the opposite. What is going to happen with when we're given the equation or the function of this absolute value? And they're asking us what is the vertex of each. So what we need to do is remember that absolute value, y equals a times the quantity of x minus h plus k. So I need to figure out what h is and what k is. So I know, looking at this, that there's nothing behind that x. So that tells me if I want to expand this function here, it's x minus nothing. So that means h is nothing. It's 0. It has a 0 as the h value. And then if I want to do my k value, we see that there's a -8, so it's plus -8. So my vertex is just going to be, my h value is 0, and the k value is -8. And that would be my vertex for that function. We're going to look at another example. Looking at 46, we see there's several things getting changed in this function. It wants us to write our vertex for each of these absolute values. So we're just going to do the one that's on the left. We notice, remember, h is inside the absolute value. H is behind that x, and the k is in the back. So I'm actually going to do both of these because number 47 is unique. So looking at this value, remember, we're going to pull out that h value of +2. And remember that the formula is x minus h. So when you plug in a positive value for h, it does not change the operation in front of it. So h is +2. And then we just carry down what they said for plus +3. So h is 3. Looking at 47, we notice something's a little bit different. Inside the absolute value, they have a plus sign, but the formula for absolute value equations or functions is x minus h. So if I have my operation change, that means I could not have plugged in a positive number. That means that h had to be negative. And in this case, it had to be -1. So if I revert my plus sign back to a negative, I see here that x minus is part of the formula, but we have another -1 behind that x minus. So in this case, my h value for my vertex is -1. And then if you look at behind the absolute value, you see that it's -1, so that y value is also -1. So my vertex will be -1, -1. Looking at the fifth slide, we see that it's asking, without graphing, identify the vertex in the axis of symmetry. So once again, we're just going to quickly review the h value here. There's a minus sign in front, so that means they plugged in a +4. And there's no number in the back, so that makes k 0. For your axis of symmetry, you have to remember that your axis of symmetry, when you graph it, is that imaginary vertical line. So if I graph this point 4, 0, going over here to 4, and I put my vertex, I know there's this imaginary axis of symmetry. You can't see it, but it is there. That is what makes my graph flip from one side to the other. So if I drew my right leg, this axis of symmetry will reflect it to the other side. Therefore, my axis of symmetry is whatever the x value is of my vertex. So in this case, x is going to equal +4. Now, going a little bit, changing our tracks a little bit, we're going to stop looking at absolute value equations for a minute, and we're going to look at linear inequalities. So we're going back to Algebra 1, where we are talking about slope-intercept form, y equals mx plus b. We know that our rate of change is the coefficient of our x variable. So your m is just whatever your slope is. In this example number 50, we notice that there's a variable missing. We notice that x is missing. So in order for x to be missing, we have to multiply it by 0. Because if you multiply anything by 0, it disappears. So my slope for this example is just 0. All right. Now, if I were to graph that slope, and I always tell my students, if you have an integer, a natural number, or a whole number, you're going to always want to write it as a rational number and put it over 1 to make it a fraction. And then that way you can graph your rise over your run. And next to our y-intercept, our b value is the number in the back, which is -2. And just remember, a y-intercept is always a point 0, comma, whatever that b value is. So it's going to be 0, comma, -2 for this example. And I identified my slope and y-intercept. For the problem over here, we see that there is an x and a y this time. So the coefficient of x is just 3. So my slope is 3, or I can write it as 3 over 1. And my y-intercept is in the back, which is +1. And as a point, that y-intercept is 0, comma, +1.
You're really great with drawing back there.
Now, if we look at these linear inequalities, it's the same two problems that we just looked at. We see here that y is greater than or equal to -2. We already talked about identifying slope and y-intercept, but there's more to graphing linear inequalities than just graphing the line. We need to be able to figure out what solutions make this statement true. So if I look at my line of -2, I know it's a flat line going through -2, just making a short little sketch here. Will these values on this line be true? So if I pick any y value, I notice that my y, if I choose -2 and say it's greater than or equal to -2, is that a true statement? Well, I can assume that -2 is equal to -2, so that is a true statement because of this equal sign that is at the bottom. There's an equal sign right there. So whenever you see an equal sign, your inequality is going to have a solid line. Now, this concept also applies to other types of functions. So this is going to follow us when we work on absolute value inequalities as well. So it all depends on if there's an equal sign or if there's no equal sign. And looking at 51, I just see a greater than symbol. I don't see an equal sign, so there's no equal sign. Therefore, my line, or any type of line that I draw, would have to have a dashed line, because if I said that -2 was less than -2, that would be a false statement. That is not a true statement. So I can't say that. Therefore, I have to show the reader that my line or my function is dashed, telling them that those solutions on that boundary line are going to be false values for the solution. After you figure out your boundary lines, we have to figure out how we're going to shade. So if I look at number 50 again, we see that it says it's greater than or equal to. The only part of this that tells me where to shade is the greater than part. When we think about greater than, we think about numbers that are bigger or numbers that are more. So a shortcut to remember, greater means we're going to shade above our line, okay? So if I had that flat line again, for this example, it was an equal to, so it was solid. My y-intercept was at -2. I only want to shade numbers that are bigger than -2, so I want to shade all the numbers that were above it. So if I look at my plane here, I'm only going to shade numbers up here. So I'm going to shade all of the numbers that are bigger than that, above that line, okay? Now looking at the second example here, we see that it's a less than symbol. And if I just draw a graph here really quickly, we had a +1 y-intercept, and it was a slope of 3, so it would be up 3, right 1. And we said that there was no equal sign, so it's going to be a dashed. Now, when we are shading, we know less than means numbers that are smaller. So we're going to shade below. I only care about the numbers below my y-intercept. So if I look at that y-intercept at +1, the numbers smaller than that are 0, -1, -20, -30. So all these numbers down here. Okay? And now what I like to do is remind my students to just keep shading and follow your boundary line, and then shade everything that is on the side that you started shading with. Okay? So I, once again, like to use my y-intercept as a key position to look at to compare which side I shade. Which side is bigger than that y-intercept? Which side is less than that y-intercept? We are going to review graphing again. We notice, looking at this problem, it's y is greater than or equal to 1, x plus 7. So remember, if there's no coefficient in front of a variable, we assume it is 1. And then since it's our slope, we like to write it as a fraction, so I'm going to put 1 over 1. And then my y-intercept is in the back by itself, that constant, which is a point of 0, 7. So on your graph, you go up to 7 and put your point. So I plotted that, and now I'm going to use my rise over run. I'm going up 1 unit, and I'm going right 1 unit. So up 1 box, right 1 box, up 1, right 1, up 1, right 1. Since it's a line, I know it's a linear inequality. I'm going to do the reverse now. I'm going back to my y-intercept, and I'm just going to go down now, but left. I'm just going to make the pattern, make my line. All right. Looking at our inequality here, I see that it's greater than. So I'm going to shade above. And I know that it is equal to, so it is a solid line. So I'm going to connect all my dots and make a solid line. And I'm going to shade above. So if I look at my y-intercept of positive 7, numbers bigger than 7 are 8, 9, 10, all the numbers up here, 8, 9, and 10. Since I shaded that side, I'm going to continue shading the same side I'm on and just not go over my boundary line. And that's how you graph linear inequality. If your equation, your inequality is not in slope-intercept form, I highly suggest that you do put it in slope-intercept form, because if you graph your intercepts here and you don't realize that using this problem, if I solved it, I had to subtract 4x to both sides. I got negative 3y is less than negative 4x plus 3. Can't combine these two because they're not like terms. So what we're going to do, instead of combining them, I need to get y by itself. Remember, that y has to be positive 1. So if it's not, you divide it by that number. And I divide every single term by that number. And when you divide an inequality by a negative number, you have to flip your inequality. And we know negative divided by negative is positive 4 over 3x. And, oh, this should be a 2. This is negative 2/3. Now, I'm not going to graph this one just right now, but remember, if you multiply or divide both sides of an inequality by a negative number, you have to flip your inequality. So, majority of students will not remember that I'm shading the opposite of what I wanted to because they tried to graph this function without solving it for y. So always try to get your slope-intercept into slope-intercept before you graph it for inequalities. And we're going to finish up looking at absolute values. So for an absolute value equation or an absolute value inequality, you need to graph your vertex first. So we're going to look at our vertex. I know it's h comma k. Looking at the inside of my absolute value, our formula is x minus h. This plus sign changed. So that means that they substituted a negative 2 in for h because the operation from my formula changed from a negative to a positive. So it's really x minus negative 2. And then if we look at the back part, that constant is negative 3. That is my k value for the vertex. So if you're graphing an absolute value inequality or an absolute value equation, you're going to do the same thing. You're going to first plot your vertex. So I'm going left 2 and down 3, and I'm putting a point. The next step that you're doing is identifying your factor. My A in front of this x, or the x absolute value, is -1/2. This negative tells me that it's reflecting across the x-axis, and this 1/2 means it's compressing. It's getting flatter, wider than a slope of 1 would be. So since it's negative, I'm going to go down and right. So I'm going to go down 1 and right 2. And I'm going to keep following that pattern, down 1, right 2, down 1, right 2. You would be doing this for either an absolute value equation or an inequality. Now remember, it's an absolute value inequality here. So for either example, if it's an equation or an inequality, you need to graph the reflection factor of A, which would be down 1 and left. So I'd have to go down 1 and left 2. Down 1 and left 2. Down left 2. Down left 2. So for an equation or an inequality, you are going to have to reflect the A, the original, the right leg, and the left leg. After that, if it's an equation, all you do is connect your dots and make straight lines. They're solid, you're done. For an inequality, you have to look at your inequality. Since there's an equal sign, it's a solid line. So I'm going to connect my points. All right. Next, the symbol is less than. So I only care about numbers smaller, so we're going to shade below. So if I look at my vertex, it's right here. I only care about numbers that are below it. So that's where I'm going to shade. I'm going to shade the entire area of this graph that is below my V. And so you're going to be shading inside the V. And that is what you need to do. So remember, absolute value equations, you do everything up until you plot all your two legs and make them solid. For inequalities, the points can either become dashed lines or solid rays. And then you have to shade above or below. All right? There's just another example here. And then you guys should remember how to do transformations. So looking at the last problem, we'll look at it here. We see H is 1. That tells me it's a horizontal shift. So I'm going right 1 unit. -5 in the back tells me that's my K. So I'm going to go my vertical shift. So I'm going down 5. And if you look in the front, A is just 1. So there is no change for my factor. Your factor can have a stretch, compress, or reflect, depending on if that number is bigger than 1, such as 2, 3, 4, 1, 1.5, it is stretching. If it's a number that is between 0 and 1, such as a fraction, then that's smaller than 1, then you're going to have to say compressing. And then if that number is negative, we have to identify that it is reflecting across the x-axis. And that is what your test is going to be on. Please let me know if you have questions. It is open note. Use all the resources. Do everything possible. Do the best you can. You have a great day.